All right, we are going to do lecture example number 12. And that one starts by telling us that 5 liters of nitrogen react completely with hydrogen at a pressure of 3 atmospheres and a temperature of 298 Kelvin. How much ammonia in grams is produced? So first, let's make ourselves an equation. So it's going to be nitrogen reacting with hydrogen to form ammonia. And you balance that. We've seen this equation lots of times. 2 on the ammonia, 3 on the hydrogen. The question is nice. It tells us that hydrogen is the excess reactant, or that we don't have to worry about hydrogen. And then from the parameters given about nitrogen, we are going to find how many grams of ammonia are formed. So basically, like any stoichiometry problem, we're going to take the info it gives us about nitrogen, we're going to convert that to moles, we're going to use the fact that there is a 1:2 ratio between nitrogen and ammonia, and then once we find moles of ammonia, we can convert that to grams of ammonia. Now, what information do they give us about nitrogen? They tell us that we are using 5 liters of nitrogen. Tells us that the pressure is 3 atmospheres, and it's happening at a temperature. So that's our volume, that's our pressure. Temperature is 298 Kelvin. We're going to want to find moles, and then it looks like we're shaping up to use the ideal gas law there, and R is going to be 0.0821 atmosphere liters per mole Kelvin. So we can set up that equation, solve for moles. So if PV equals nRT, divide RT over to the other side, moles is going to equal pressure times volume divided by R times T. We can plug in our numbers. So it's going to be 3.00 times 5.00 divided by 0.0821 times 298. So 15 divided by 1/10 of, so 30. So it should be about half a mole. I got 0.6131. So that comes out moles of nitrogen equals 0.6131 moles of N2. So that's complicated, but that's our first step in the stoichiometry problem. Find moles of the given substance. Now we're going to use a mole ratio to find moles of ammonia. So it is 2 moles of ammonia for every 1 mole of nitrogen. So that means we're going to produce, well here, that times 2. So it's 1.226 moles of ammonia. And ultimately it asks for grams. So why don't we'll add on another conversion factor there. Ammonia, so 1 mole of ammonia has a mass of So nitrogen is 14.01, hydrogen is 1.008. So it comes up to exactly 17.034 grams of ammonia. So 0.6131 times 2 times 17.034. I get 20, so the calculator, the whole number comes out to be 20.887159. Looking back to the original problem, 5 liters, 5.00, 3.00, 298. So I'm going to round that to 3 significant figures. I'm going to call it 20.9 grams of ammonia. And that's going to be our answer.